can get my slides set up here. I'll let Renee help here. And actually, it's a really fantastic intro because I spent the last 8 years building a mobile security company, mobile security and mobile forensics. And when you get busy doing that, it's sometimes hard to take a step back and think about why we're doing this. And as somebody who just recently traveled and had to swipe my passport and all those things, you know, it's not just about jailbreaking phones and doing exciting research and finding vulnerabilities and building a business. It's really about some of the things that Renee touched on and what we're here to talk about today. So it's great to be here to kick this off. And I would say that, you know, my approach personally, and then maybe more broadly, my company, which used to be called Via Forensics, we've changed our name to now Secure, it probably took a little bit less standard approach to maybe what many folks here have focused on. We started out in the forensic space. And as I put this slide deck together, a bit about, a good part of this is basically a history of our company and kind of how we evolved from a forensics capacity into mobile security. And so, you know, my role is I started the company back in 2008. I'm the CEO and co-founder, and my background is in computer science and, of course, in the forensics and security space. I've written a couple of books and just completely consumed by this topic. It's a pretty amazing and exciting space to work in. I want to spend just 3 or 4 slides just kind of setting up the problem as we see it. And as Renee kind of touched on, I mean, we're industry focused. So we work with large enterprises to help them secure mobile. And so a lot of the academic research is fascinating. We're pretty empirical. We're pretty kind of practically focused. How do you go out there today and walk into a large bank that may have 400,000 devices of their own and have them operate in a way that they feel like they're at least managing mobile risk, not solving it, not eliminating it, but trying to take some steps to kind of address some of that risk. And the thing that's been fascinating for me, and I think for our company, is that as a mobile security industry, not the academia side, we've spent billions of dollars solving the wrong problem. We've been focused on, as an industry, malware and antivirus. And the reason we've done that, I think, is because in traditional PCs, that's what we saw. We saw viruses, we saw malware. We had an entire industry that spun up around that. And we had, most importantly, the press and the general public that understood the problem. So when mobile devices came out, and I've been using mobile phones obviously well before the smartphones, but when iOS and Android really hit, the industry said, how do I get my spot on this phone? How do I stake out my territory? Well, there was already a common language, and it was antivirus, it was malware. Of course, all of us in this room know that things like sandboxing and the App Store and Play Store and things like that have, I think, generally eliminated the biggest part of that risk. Sure, there's some malware out there, there's some bad things that happen, but in the big picture, it's really not about malware. The big picture is really about leaky and insecure apps. And so this has kind of been a guiding principle for us. We've largely chosen to ignore the malware problem. I mean, not completely, but if we find signatures of known malware, great, let's put them in there. But we think the much bigger problem are leaky and insecure apps. I'll show you a video in a little while. We have an analysis rig, dynamic rig for lack of a better word, that automatically tests mobile apps without any human interaction. And we've looked at about 600,000 apps right now. We run them through constantly. And today we're focused on Android. We've got a rig up and running that automatically tests iOS apps in the early stages. But when we look for high security flaws or privacy flaws, we're approaching about 50% of the apps exhibit some sort of security or privacy flaw. And that's a pretty staggering number. Malware would essentially be 0.18% or whatever Google's number is, and Apple's even smaller. But leaky and insecure apps is a huge number. And we have to spend a lot of time educating industry about this problem. A thing that's also been very intriguing to us is to look at ad networks. And of course, I think the internet and mobile apps are largely being driven by advertising and what can we learn about the end user. And so when we did this analysis of the mobile apps, 50% of the apps are sending data out to ad networks, and sometimes we'll see up to 15, 16 ad network SDKs in a single application. So makes it very clear to us is that obviously if it's free, then you're probably the product, and they are interested in learning what you want and what you like so that they can advertise to you. So this is really kind of the backdrop of what we think is driving mobile security. We have an absolutely amazing research team at Now Secure. Pao is here today. He'll be giving a talk tomorrow. And we've got this fantastic group that's constantly looking for flaws and then figuring out how do we automate the detection of these things and move into a more secure ecosystem. So Ryan Welton is one of our researchers, and he presented this, I think, at Black Hat London a couple months ago. I'm not going to do the live demo, but I thought it was important not to just say, hey, mobile apps are, taking our data and putting out to ad networks and they have security flaws, but let's talk about one specifically. And we can do demos later if people want to see this. So AdLibber is a popular ad network that's out there. And there's basically a remote attack that we can launch against that. AdLibber goes out, it downloads a zip file that actually has a DEX file sitting inside of it. This is how they serve up their different ads. Of course, none of that was done with TLS, so anybody sitting between you and upstream could kind of intercept that request and then put a specially modified DEX file out there. And basically, we can get remote code execution. The interesting thing about this is not that we can do that. I mean, Android's a pretty versatile platform. There's a lot of kind of problems out there. But if you think about scale, AdLibber, Korean company, probably been around a few years. I didn't really look into their history. They have about 8 billion ads they serve up on a monthly basis. Because, again, mobile apps are powered by advertising. So 8 billion instances on a monthly basis where anybody that's upstream and has a position on the network could potentially intercept a request and get remote code execution on that device. That's a lot of ads being served up. And it's a lot of opportunity for somebody, let's say, that had an ISP level access, that maybe had some sort of nation state access to be able to sit in there. And these guys are not that big of a company. But by deploying this advertising technology, you can easily get into billions and billions of impressions a month. AdLibber is pretty widely used, obviously. Our kind of target app, just to take a look at this, was something called SimSimi. Does anybody here play this app? Anybody know about this? So I had to look into it, and basically, as I understand it, this is an application that you run, and it basically curses at you and uses inappropriate language, and you interact with it. So about 10 million to 50 million people have found this to be an interesting application. And basically, this is only going to give you remote code execution within that specific app. But of course, once you've got that, you could decide how do you get further access to the system. What was interesting is as we set up MIDM proxy and we're looking at the different traffic, within the first 2 to 3 minutes of running the application, setting it up, selecting your language, and getting your first egg or whatever it is that they send you, this was the data that leaked out. And of course, all of it was done over HTTP in the application. And I just take a minute to, typically when I'm talking to enterprises, and here, you guys will get this, I don't have to go through this kind of ad nauseum, but there's a lot of sensitive information in here that gets leaked out. Obviously IMEI and MAC, serial numbers, the country, device, precise geolocation. They're typically targeting ads, based on where you're located. Some of your cell information, some unique identifiers that are used across multiple apps. Interestingly, they have a root check. I don't know how effective it is, but they're looking to see whether or not your device is rooted, and then some information about the actual device and the application that it's built into. So all of that is being leaked out over HTTP, and it's going to 3 countries. And I can tell you, as somebody that spends a lot of time working with large enterprises, especially in the U.S., they care very, very much about where their data is going. And so it's always helpful to be able to look at a particular application and data and try to understand, well, where's it being sent? So in this particular case, a lot of the traffic went to the U.S. Understandably, some traffic went to Korea because that's where the company's located. And then there's a particular sensitivity around intellectual property and whatnot in U.S. companies. And so I think people are always kind of saying, well, what sort of data makes its way to China? And what was interesting is in China, it's this particular IP address. These are the ones that were going out there and doing the checks to see whether or not your device was rooted or not, and then sending that information back to China. I'm sure there's very legit reasons why, or maybe, I don't think there's malicious people sitting behind every single request. But it is very intriguing or very important, I think, to large enterprises to have a sense for where's my data going, what data is being sent, and how are people getting their hands on it. So again, I'm going to skip the exploit here and not do it, live. If folks want to see it, I can show it to you guys afterwards. But it's pretty simple. You just, you can run minim proxy your traffic through the device, and you're looking for a particular file that gets requested. I think it's called classes.dex.zip. And as soon as you see that, we just simply swap out the ad that AdLibber would have served up. We put on our own payload, and from there we can download BusyBox and get remote code execution through a reverse shell. Okay, so that was just a little bit of background. We as an organization don't see malware as the problem. We see leaking insecure apps as the problem. But what I want to do is kind of take a step back and walk you through, well, how did we get where we're at today, starting out in forensics? In forensics, obviously, is primarily focused on crime, court cases. As I'd like to say, putting Humpty Dumpty back together again and figuring out what happened. So back in, and this is a little bit of a history, a little bit about myself and a little bit about the company. I think most good innovation comes out of boredom. I had spent 6 years as a CIO at a company in the US, about $1 billion company, had solved all their problems. I was pretty bored. And we actually hired somebody who was a felon, unbeknownst to me. So he was in federal prison for 2 years. He had stolen $1 million from his previous company. And when he got out of prison, he faked his resume, and then we hired him into our data warehousing group, where he had access to all of our vendors, all of our pricing, and all of our customers for over about 30 years was online, but it was about a 100-year-old company. And so we needed to, after we figured this out and fired him, we needed to go in there and figure out what did he know, what did he do. And I considered myself a pretty technical CIO. I enjoyed tinkering. I did a lot of stuff with our Cisco routers and programming and things of that sort. And I decided that, because I was bored, I was just going to do my own forensic investigation instead of paying some company to do it. And I was absolutely stunned at what I found, which was essentially a complete record of everything that he'd ever done. And again, for folks in here that have kind of studied forensics a little bit, this probably is not, very shocking. But it was that point back in, I would say, 2007, late 2007, early 2008, that my entire kind of focus shifted and said, wow, there's a world going on here behind the scenes that I wasn't even aware of, and what can I do with this? So the first thought was, well, go get certified, go figure out what this forensics business is about. And especially in the US, it becomes really important to become an expert witness. So this is the federal court system recognizes you as an expert and you can testify in court. I know a lot of forensics people that have spent 5 years, 8 years, 10 years in the business and never had a case that ever was an expert. By sheer luck, which sometimes feels like the story of my life, the very first case I landed ended up in federal court. I was pretty nervous. I was sitting there and I was testifying about a case that had involved an airplane that had slid off of a runway and had killed some people. And so within a few months of kind of starting the company and getting certified, I was an expert witness, and it really started my kind of foray deeply into the forensics world. And so began to develop a business around that. Did a little bit of computer forensics. It's really tedious. It's really boring. I would recommend don't go there. The world is all going mobile, and we quickly saw that. So we shifted our focus from computer forensics into mobile forensics, and we built a business around that. And it was around 2010 that I was sitting here, and I was doing a case. I think it was a departing employee case. These are the most common cases that forensics businesses get. So some sales guy leaves the company. The company gets worried about what information, price list, customer list that he took with him, and so they hand it off to a forensics person to go do an investigation and then settle with the person so that they don't steal that information. And part of this case involved not just a computer, but looking at this person's phone. And what I became amazed with is as I was flipping through and looking at thousands of lines of data, trying to figure out what was on his device and what did he try to delete, I ended up finding, of course, his full name, all of his credit card information, his address, his bank statements, balances, mortgage payments, absolutely everything was sitting there on the device. Of course, none of it encrypted, just sitting there in plain text. And I said, holy cow, what is going on here? This seems to be a problem because clearly this guy wouldn't have stored the information on his phone. The banks don't need it. The carriers don't need it. In fact, the only people that could actually use this information would be some cyber criminal, some bad person that gets their hands on that phone and could use that to steal his identity. And so this was really that kind of second turning point for us, where all of a sudden I realized that forensics had something very, very important to say, a very, very important involvement in the security of smartphones. So during that time, I had written a couple white papers, and we actually turned those into a couple books. Katie Stremka and I wrote the iOS book. We've got an Android forensics book. We're actually starting on second editions. For the longest time, the publisher kept asking me to go back and rewrite these, update the books, and I said, no, we're not interested in doing that. But I was able to go back and work a deal with the publisher and say, listen, I'm going to write a second edition. I'm going to release the entire book for free on our website. I'm going to put it out in a PDF that's freely downloadable, and I will let you distribute it in a printed format if you want. And they said, oh, okay, great, we'll do that. So we're excited to be able to go back and write second editions of the books, and they'll be fully distributed and released for free on our website. And then people presumably will want to buy them and have them as references. We'll see how well that works out. So in addition to those books, as a company, we've written 5 books involving mobile security and forensics, and we're actually got 2 others that we're in the middle of writing, one about mobile incident response. So I know there's a talk later in this conference I'm very interested in catching about that topic, and then mobile app testing. So all of these books will be released on our website for free, and you'll start to see information coming out over the next couple of months. So in preparation for this talk, I actually went back to the forensics book that I had written and took a quick look at a chapter. I wrote chapter 7, I wrote all about application analysis. And if you're writing a book and you have targets for how many pages and how many words they have to be, quick hint, when you include the output from commands, it's a beautiful thing, because all of a sudden you have to show the commands, you have to show the output, and the book gets longer. And so I was going back and looking at that chapter and trying to understand, what did I say back in 2011 about app analysis? And there were 2 interesting statements that I kind of pulled out. The first one's obvious stuff, but when a forensics person gets handed a phone, or sometimes a forensics person gets handled a file system dump or a root partition, you just have a bunch of ones and zeros, right? You've got to try to make sense of this. And so how do you take that raw data and bring some context and analysis around it to actually bring value to it? Otherwise, it's just noise. And then I wrote an interesting statement in the book which basically said, but of course, doing app analysis is a one-off thing. We could only do a couple apps. I think I selected 10 applications as an example. And I said, there's no way. I said, it'd be nearly impossible due to the sheer number of apps, and then for Android in particular, the number of specific devices, to ever do this at scale. And I haven't thought about that statement until 4 or 5 days ago when I realized this conference was coming up and I had to get my slides done. And I jumped back into that chapter and just took a quick look. And so the book, this is what it'll look like when it's online. Chapter 7 actually just has a whole bunch of apps where I singled out the app, talked about the actual package name, the version, what phone I ran it on, who was the developer, and then I go through, thinking as a forensics person, and I go through the different directories, the files, the types, and I explain what is each file, what is each type, where's the data located. So if a forensic analyst is ever out there saying like, hey, I need to go figure out, where can I find this person's different email aliases, they could go through this and kind of find that. So it was very intriguing for me to see this. This works. It worked great. I sat there. I wrote a Python script. I would run the apps. I would download the data directory. I would parse it out, and then I would copy and paste it into the book here. But you can't do that at scale. We can't go anywhere with that. If you fast forward to where we're at today, and this is really the brunt of what I want to share with you guys, it's a very different world now. And unbeknownst, I didn't ever think about what we tried to do years ago, but unbeknownst to me over the last 5 years, we've actually built a system, and I think other researchers have done similar things, that can actually do this type of work, but do it at scale. So in order to take that individual, I ran the app on my phone, I pulled out some interesting directories and files, I figured out what gets created and what gets deleted and what we might care about from a forensics or security standpoint. In order to do that at scale, there's a couple things you need to do. First of all, you need to be able to do both static and dynamic analysis of the mobile applications. And When we do dynamic analysis, in particular for Android, but the same applies true for iOS, we actually obviously have to instrument these phones so that during runtime we can collect as much information as we want. So in Android, we instrument the Dalvik VM, but we also instrument things at a kernel level. Pao and I were having breakfast this morning and we were talking about GPS location. So we want to be able to control what information we pass to the app so we can kind of track that data and see if it ever pops up somewhere else. And you can go in there and at a Dalvik layer and kind of the standard API layer, you could go in there and say, hey, anytime somebody calls these APIs for GPS, feed them this information. But developers, especially on Android, find interesting ways to do things. They can skip the standard APIs. They can do more direct calls. And so what we ended up finding is that even though we could patch the Dalvik VM and instrument that, what we really needed to do was also do that at a kernel level. And when we went through the work that required to do that in an intelligent way, the value that we got was well beyond what we expected. So we get an enormous amount of data back, and now the key is to parse that down into the core properties that matter for both security and forensics. One of the other key things that we do is we store everything. So any sort of artifact that ever gets generated during the process gets stored. So that includes PCAP files, the file system, the read-write information that went on there, SSL session keys so we can go back in Wireshark and recreate things in the future if we need to. And going all the way down into the actual every single function that was called so that we can see what functions were called, what were the parameters that were passed into those functions so that we could go back, for example, and try to understand how was data encrypted. You know, for forensics people, things like WhatsApp is really important, because there's a lot of information that takes place in these instant messaging and these messaging applications, and you've got to be able to figure out, all right, in each new version, did WhatsApp or did whatever some of the other popular ones out there, WeChat, did they change how they encrypt the data that's at rest? What are the keys and the things that you need if you're going to be looking at kind of dead data just sitting there, to go back and decrypt that? Do you have the things that you need to do that? So we capture a lot of information through both static and dynamic analysis. Mostly what we do is command line, and we're starting to move more and more of these to websites and make it easier for people to do it who are less familiar with the command line. We support both manual and automated. So one of the things is we were fortunate enough to have a couple DARPA projects. So DARPA is the DoD's advanced research group in the US, and we were helping secure mobile apps. And one of the things that we found is that for that particular program, they were using a bunch of open source tools and trying to automate mobile app testing. And we came in and did some manual analysis, and every app failed our basic tests. And one of the big lessons that we learned is that human in the loop is absolutely critical to securing mobile. So automation is the only way to handle this at scale, but you can never take the human out of it. So how do we build tools that can do a lot of good, smart automation, but at any point in time, have that human pick up where that automation left off, and start jumping down the rabbit holes and really looking for the flaws and the weaknesses that we just simply haven't built into the automated systems. So supporting both manual and automated, and to do that, we created a technology for both iOS and Android that will automatically run mobile apps, and I'll show you a video of that in just a second. Now, one of the things that we ran into is that we started out, I think, like probably most developers, and we started out using like RDBMSs like MySQL or even SQLite, and we ended up finding that the sheer volume of data that we were creating through this automated process, we simply couldn't keep up. And so one of the things that we did, for better or for worse, is we decided that we needed to develop a data store that was very scalable and very lightweight. As many of you guys know, if you're building these systems, the simpler that they are, the better we can run these things at scale. So we came up with a simple set of APIs that would scale both horizontally and vertically, and we were looking for ways that we could efficiently store data and then quickly move them over into warm stores and cold stores if the information was outdated. We still wanted to gain access to that, but needed to be able to kind of intelligently store that and put it onto cheaper, slower storage. Another key property for us was we needed to be able to stream technology. So we constantly have data coming in, and I'll explain where we get some of our data. And we're not always ready to process that data. And so sometimes we come up with a new technique, a new idea, and we need to go back and be able to replay a data stream and then reprocess information. So that was another key property for us. And we handle all of our indexes and whatnot in a data access layer. What we found was trying to build out an indexing mechanism that was smart, in the actual data store layer became something that, you built out a much bigger, much more complicated system. So ultimately, we settled on a technology called LevelDB. So this is actually written by Google. It's used in Chrome and a number of other places. It's a very simple key value pair store. We've hired some folks. Paolo Fragamani is our VP of Engineering. And we started to hire core team members out of the LevelDB group, Julian and a number of other folks. And so we built out a very simple data store that scales nicely, and this is a core part of how we kind of get this data in an accessible format. One of the interesting things, and you're not supposed to be able to read this, you could zoom in and look at it if you want, but one of the interesting things is that app analysis for mobile is constantly changing. It's never ending, right? Android M comes out, iOS 9 comes out, Touch ID. No matter what, the one guarantee we have in mobile is in that 3 to 6 months, everything's going to look a little bit different. And so one of the other things that became really important was the ability to go back and reprocess, to add new engines in there, to recheck things in a way that you could just kind of re-queue up 500,000 apps and say, hey, we just found this new flaw with OpenSSL. Go test these 500,000 apps and re-look for this flaw. Or go through the properties that are out there and see if we can determine whether or not these apps might be vulnerable. So for those of you that really get into app analysis, you know that it's a very complex space and kind of constantly changing. I threw this in kind of at the last minute, something that I'm particularly interested in. I call this the Stack Overflow syndrome. For those of you out there that hack code, you guys ever go out to Stack Overflow and say, how do I do this thing, right? I want to do a certificate manager, and I have more important things to do. I'm sure somebody's written that, and we go for that one that gets a little checkbox, like, this is the way to do certificate management or validation. Great. Copy, paste, pop it in my app, and go. And one of the things that we found is that, again, what we call the Stack Overflow syndrome is somebody writes a piece of crummy code, and it ends up in 10,000 applications overnight. And so what's been intriguing to us is, anybody use a technology called Elasticsearch? So you could use Splunk if you have a lot of money. Otherwise, Elasticsearch is this nice kind of indexing technology based on Lucene, Java-based engine. But anyway, really good at indexing text. GitHub uses it behind the scenes for all of their source code if you ever search for code on GitHub. So what we do is you grab your IPAs and your APKs, you reverse engineer and decompile the apps, index that source code, and then you identify a problem, right? One of the things that came out a couple years ago is called the secure random problem. There was an issue with how Android primed the pseudo random number generator. And so there are different ways, I don't remember the specifics about how you use urandom or whatever. And here's the right way to seed the number, and here's the wrong way. And so you go out and you find an interesting kind of code snippet where you can say, this is the wrong way to do it. And now you have the ability to go back and search over 500,000, 1 million, a couple million apps and just find that particular flaw very quickly. No more analysis needed. Identify bad code, go find it. So this is kind of an interesting area for us where we're beginning to look for those app flaws and characteristics and then immediately kind of regression test that against all the apps that we've seen out there. But the core of what we've been focused on, call it for the last 18 months, and is really kind of coming to fruition now, is this basic concept that I think will make sense to everybody in here, which is, all right, let's go in and set aside key pieces of data that we care about. And this list is extensible, and you can put anything that you want in here, but let's go ahead and control these values. So the GPS location. We have a set GPS location we pop into every app. We can change that at any time. So how does this app behave in Vienna versus Chicago versus Pakistan or something like that? But you go in there and you take the data that you care about and you control that, and you make sure that you can identify that within the system. Then you go out and you exercise the mobile apps. In the early days when I was writing the book, that meant fire up the app, install it, run it, type in information, capture your PCAPs and your file systems, and then go back. And this is what we've obviously automated so that we don't have to do that by hand anymore. You do static analysis on the applications, and of course you do dynamic analysis while you're exercising the application. And primarily, it really boils down to these two things that we're looking for. How is data transmitted? And then how is data persisted? And can we identify flaws in mobile apps? And this is where our forensics thinking comes in a very empirical way. Can I go out there and say, not because I built some static analysis engine that looked at your code and said, I think this is bad, because we went out there and said, I just saw your credit card in plain text, or I just saw your credit card in MD5 or some silly XOR or URL encoded, things of that sort. So as we're exercising the mobile apps, we're constantly monitoring, and I think we have a list of 15, 18 different types of encoding that we look for. But we'll automatically take those values and MD5 them, for example, and try to identify if somebody is sending sensitive information, but in a way that a reverse engineered app with the right kind of attacker on the other side could say, hey, I think I can go out there and find information that would be helpful for them. So we're constantly monitoring that, and then as we find these different values, we just store them in that key value pair in a very ultimately searchable format. So the core to this, of course, to do it at scale, is to have a way that we can inspect and automatically run mobile apps. And so we built something, UI Automator. I think that's literally what Android or Google calls part of their automation framework. So we're not that creative in the names. But we basically go through and we build out a view hierarchy of every mobile, of the application. So we know, what sort of GUI elements are presented to the end user, and we can just kind of inspect them and see them. So things like, most of the time when somebody wants a username, they create a field and it says user or username. So we're just kind of building out a very simple model that goes out and looks at the hierarchy of the GUI, and then identifies those different values and allows us to automatically fill in those properties, hit the button, swipe left, swipe right, up, down, whatever it happens to be, and exercise that application. Our first versions of this, and Pau's been very involved in it, was really focused on doing that on Android. And the most recent work that we've done is building this out for iOS. So I might end up needing help here. We'll see if I can figure this out. I have a video, and I want to just show this to you guys. Okay, and I got to drag this over. And then, let me see if I can find my mouse. Okay, so I'm going to let this run in the background, and I'll just describe this a little bit. But this is basically Jake Van Dyke, one of our researchers, recorded this for me last night. We had a video that was really old. We've got racks of devices. Today they're Nexus 7s. Oh, yeah. And Pau's working on the Nexus Play stuff right now so that we can, because you can't buy these devices anymore. But behind the scenes, we just start queuing up a huge list of mobile apps, and we just say, hey, go push those APKs to the phones, automatically run them, inspect that hierarchy, and just start inputting data and collecting it. So we've hooked the kernel, we've hooked the Dalvik VM, we've hooked all these guys up over USB, and behind the scenes, you'll see that we can see, let me get the pointer here. For example, right here, you can see that we're downloading the data local temp, we're installing it, and then we'll end up grabbing, for example, here, data.data.com.box.unzip. We grab every one of the files that are out there being created, and we tar gzip them so we can go back. We can see that this particular application is, storing some data out on the media directory. We've got different loadable libraries out there that might be interesting for us to go in there and inspect. So behind the scenes, constantly, and you can see up here, it's the things trying to figure out, can it click on this button? Obviously that one's in Korean. So we've been running into some interesting properties about, like, can we automatically translate these apps? If we can pull out the Unicode and put them into a translation system and bring it back so an analyst could be able to go in there and figure out what happened. Sometimes devices crash, sometimes they get stuck, but in general, we're able to go out there and run apps and find lots of flaws in the applications and find different properties. And then, we basically make all of that information accessible through our storage mechanism, so we can index it, go back, and I'll show you kind of what that ends up looking like. So this is a 6-minute video. I'm not going to have you watch the whole thing, but you kind of get an idea of how can we take, crawl the app in Play Store, get our hands from Contagion, whatever it happens to be. Can I get APKs or IPAs, push them to devices, automatically exercise them, and examine both the file system, the static analysis, and the network analysis to find flaws in the apps. Okay. So that's kind of UI Automator in action. How am I doing on time? Okay. We just went through that video. Now I'm going to just take you through some slides, and apologies, these are kind of command line stuff, which is typically where we start out, and just give you some ideas of how we do this. So here's an example of us just submitting an application that David Weinstein, he's our director of research, submitted an application that he just kind of hacked together. And then he can go back and query it and basically say, hey, give me any details about this application. So that's a really simple function where we just queue this thing up and then go out and get some properties about it. So in this particular case, you can get the URLs of the developer names, which is really helpful. So one of the things that we found is because so many apps are failing basic security and privacy tests, that we had to build an automated disclosure system just to keep up. Originally, we would just submit an app. A great example is Microsoft. They were fantastic to work with. We found a flaw in Outlook. It stored your username and password in plain. It was man in the middle against your username and password. So this was a big problem for enterprises because your credentials could get man in the middle. And we submitted the ticket to them. They were on top of it. They responded to us. They patched it, and the thing went out. And then we let our customers know as well. The problem is when you find 250,000 apps that have security flaws, you just can't send that email anymore. So we ended up building out a disclosure system that automates this information, and so we can come in here and grab, for instance, their developer emails and automatically send them notifications. And then we can look at, just kind of, for instance, the SHA-1, which becomes important if we've seen an app before. And everything that we do, we end up storing in S3 with signed URLs. And so we can make all of this data then accessible ultimately to the research community, which is a key goal and one of the reasons I'm excited to be here today and show you what we've been up to. So can we go out there and say, hey, if you want to go grab this APK, here's a signed URL, go do that. You can go take a look at it yourself. So this is kind of queuing up a job, looking at some of the metadata, downloading it. Basic app properties. So the concept for us was there's new reverse engineering tools, decompiler, static analysis. AndroGuard is one that we use. A lot of people use it, but there's going to be another one in the future. So we built an architecture that meant we could just plug in new engines. I don't really care what it was. There's a company called Galois. Are you guys familiar with them? They have some interesting research they've done about how 2 or 3 apps may work in concert to have some sort of security flaw. So you could go plug in some new engine. So for this example, we've got AndroGuard analysis. We just kind of go out there and say, hey, take a look at that app. Show me the AndroGuard analysis, and in this particular information, expose for me the different permissions. And there's a huge list that comes back, and you can see all the permissions. This is kind of Mickey Mouse stuff. Everybody does this. But we've done it in a way that's very repeatable and a very consistent way to go in and query this information. Where things start getting a little bit more interesting is when you start doing static and dynamic analysis, all right, well, let me go out there and try to identify any sort of network issue. And in this particular case, let's just, we looked at, I think, a couple hundred apps. And let's go out there and find flaws where sensitive data is being leaked. So this goes back to us populating our own data. And in this case, an IMEI, so this is obviously a made-up IMEI number. We know that's the one that we've been using. And just go out there and show me every app that exposes this information. And so in this particular case, we found that value is URL encoded. And then we store the full URL and we store the PCAP so you can go back and reanalyze it. So in this particular case, you can also see that it's being done over HTTP in addition to storing not only just the IMEI, but you've got a lot of other information in that URL, right? MAC address, Android type, versions, languages, things of that sort. So how can we go out, use this system and automatically find IMEI, automatically find the MAC address? So this, I think, is a taxi application in Brazil. So you can just kind of end up going through and seeing a whole bunch of different properties. That was where we were at kind of a couple months ago. One of the other things that we do is because we hook the kernel, we go out there and we're looking at, in this particular case, this doesn't even require kernel, we're looking out at Logcat, and we've got something called Stealthy Spy. And as an example, because this could be important for a forensic investigator, I said, all right, why don't you let me know every application that in a very simplistic way seems to have a field called password that it's storing in a SQLite database. Does that mean every one of them will store the password? No. We track password. We can taint that value and track it through the system. But can we just go out there and find out, what applications at least have that column name sitting out there? And that's a very simple query for us to do, and we can go out and begin to see that. Now, a lot of you guys will probably recognize this is probably a pretty standard instance where people are doing reusing the browser WebKit, and basically WebKit automatically creates a bunch of SQLite files. So it's not to say that these particular applications are storing your password, but just the ability to be able to go out at any point in time and to find that information. Another thing that we found was function tracing was very helpful. So could we come in here and use that same technique to go out there and say, all right, who's using AES? How are they using it? So here we could see these guys using Bouncy Castle. We can grab the actual SSL handshake. We can see, for instance, what files exist, what mod. We found some recent flaws where people have world readable files, 777, so we can go out there and identify all of those. And what data is getting deleted, where maybe a forensic analyst would say, hey, I don't see that data when I look at the app at the end of it being exercised, but I know that temporary files were created and I could get my hands on them using some forensic techniques. So we're able to go in at a very low level and see basically every file creation, every file delete. We extract SSL sessions so we can go back and decrypt SSL. And where we're at today is we've taken kind of those primitives and we're making them a lot easier to now query. So here's an example of a recent query where you could just say, all right, sensitive data leak, and return back to me the package name, the application, the version, and description. Because again, we've got a big system out here now that's just a bunch of key value pairs. And I changed all of these value names to really lame, made-up package names because we haven't disclosed any of these. But we literally have hundreds of thousands of flaws just sitting in this database that we're finding through the automation. So, we track personal identifiable information, URL encoded, MD5, where's data being sent, what's being sent. Who downloads zip files in plain text? We found a different number of attacks where we could do, swap out a different zip file, do a path traversal attack. So we're just interested in saying, hey, show me every application out there that ever downloads a file, a zip file over plain text. So that's very simple for us to come out here. And then we can go out and actually see the actual URLs. I changed most of these, not all of them. And you can go out there. This is the one that's the ad-libber one. So it's really simple for us now to go out there and say, you know what? For all of those 600,000 apps that we've looked at, show me any app that downloads something called classes.dex.zip. We pretty much immediately know that that app is going to be vulnerable to the remote code execution. And so it's a way to, again, to index and find this information. Who's got broken TLS? What's the specific address, IP that I obviously faked and forgot a digit there? What's the actual JS file? So we're able to come out here now and find a bunch of properties of security properties of applications. And again, all of this stemmed from forensics and kind of back in the early day of how could we build a system that automatically stored and tracked the information about applications. We took a small sample size, 5,000 apps, 4,500 apps. Yes, we can put pretty GUIs out there. So you guys are probably comfortable going command line and key value pair when you go out and enterprises are your customers. They want to see nice little charts and they can click through and whatnot. So everything that we do is in JSON, and this is pretty simple to turn into some nice dashboards. And then you think about the analysis is, and I'm going to go through this really quick because I know I only got about 8 minutes left. Now we can start looking at 600,000 apps and begin to look at some high-level properties. On average, apps require 20 permissions. We look at the dangerous permissions. You guys can change this list for whatever you care about, but we can look at what percentage of applications are having those different permissions. And we took a look at any application that has over 100 million downloads. We have a list of quote-unquote dangerous permissions. So again, you could change these. And what was interesting is that of all of the 118 apps that we looked at that had over 100 million downloads, only 13 of them did not ask for what would be considered a dangerous permission. This is information that's ultimately going to help us understand the ecosystem, to help enterprises manage mobile risk. Application download count versus number of permissions. Essentially, you can read this chart that says the more popular the application gets, the more permission it requests. We actually have another slide. I didn't throw this in the deck. The more popular the application gets, the more vulnerabilities we actually find. And we thought it would be the opposite. People are like, oh, great, we've got 500 million people that use our application. We're going to take extra care to make sure that we've got a security team and a QA team. And what we actually find is that I think the psychology behind it is 500,000 people are using our app. If I'm not on top of my game, some upstart company is going to come here and take my position as king, so I'm going to just start pumping out features as fast as I can. And they tend to ignore security, and we find more and more flaws that can get us access to 600 million phones. So that's interesting, right? I hope it's interesting, but where it gets far more interesting than static and dynamic analysis is when we begin to combine this information with additional data sources. So a while ago, we recognized that some of the most interesting stuff happens on the phone itself. So could we provide a security application that in the process of helping people secure their phones, we can collect anonymous information and understand more data about the ecosystem and combine that with the static and dynamic analysis. So we've got apps that run in iOS and Android. Those apps are used in 188 countries around the world. We've got community editions of our app testing and forensics products. Those are used around the world. And all that data flows into us. So instead of me telling you, hey, there's a taxi application in Brazil that leaks out your IMEI, we can begin to say things like, on average, we're finding that per device, 50 applications have access to, for example, all of the user account information. So when we begin to combine static and dynamic analysis with additional information about how apps are being used on devices around the world, what Wi-Fi networks they connect to, do they have pins and passcodes, we can start surfacing out far more interesting attributes about the ecosystem and the steps that we need to take to try to secure it. For our global users, 61% have a PIN or pass enabled. That's actually pretty good. I'm surprised. We want to see that number go up. 20% have ADB enabled. That's probably not great because you could potentially sideload applications and things of that sort. Unknown sources, how many people have encryption enabled on Android? It's about 4% based on our, the subsection of devices that we can see right now. And who's running the latest operating systems. Interesting property of this is across our users, that we have a couple 100,000 users that are using our mobile app right now. We see over 277 versions of Facebook, and that number goes up. I think that's an old number. I think last time I checked it was about 320. And what's interesting is clearly Facebook's going to patch some flaw in their app because it's a massive application. How many people are running insecure versions of Facebook out of those 277 versions? So it really starts to help to put additional context around this information. We have a forensics product. We offer it for free. People download it around the world. I think, generally they're trying to root their own phones or maybe look at their spouse's phone. I don't really know. But one of the interesting properties is that we can see by kernel, by phone, where do the root exploits work and where don't they work. And this is going to be really important if you're managing security for a large enterprise and your CEO, your executives that have access to the most sensitive information are going to go travel overseas. What phone do you give them? The one that Talroot works on or the one that doesn't? So by collecting more and more information and combining this in a kind of a big data play here, if you will, we're able to, I think, secure mobile in a way that becomes a lot more intriguing. So there's a bunch of use cases we threw out there. Where does forensics work on a particular device? If you have to collect metadata at the time, let's say you're law enforcement, there's been, a homicide or something, and you're sitting there and saying, well, what information do I need from this device in case they have Tencent on there, or in case they have WhatsApp? What do I need? What properties of the device do I need to be able to potentially decrypt that data? If you're just handed information and you're just looking at the raw data, what information is out there? What version of the app was run? Can you decrypt the data? What gets sent out over the network? What are the different Wi-Fi networks and the properties of those? How do you defend against these? What apps are popular? There's an enormous number of properties here. And our vision is that we've been building this system. We've kind of redone it over the past 9 months from the ground up, built an API layer, built out that storage layer that I mentioned, got an orchestration layer that you just plug in your different engines to do your different types of testing. And we're building each one of our products on top of that. That's what the enterprises buy. But what I'm excited to kind of talk to this group about and let you know is that we want to open this system up to researchers, to academia, to make this free for people to be able to go in there and to be able to upload applications and reverse engineer them. If anybody uses Radare, R2, Pancake, we hired him. He's part of our team. If you use Frida, Ole's part of our team. Pao is part of our team. So we hire a lot of these amazing researchers, give them time to go work on their open source projects, and then we incorporate them into our platform. So, this is a platform that's extensible. It's going to be open to researchers, academia, to individuals. Basically, we're just going to make the companies pay for it. And it's in a place where we want to be able to do static and dynamic analysis of apps, combining that with interesting data, so that ultimately we can use that big data play to try to make mobile more secure. I think the malware days are over. Yes, malware's out there. It's just a mobile app that does some crappy things, so let's go identify that and try to get it off of people's devices. But it's a small subset of a larger problem, which are leaky and insecure apps. And we need to start, because of the volume of apps that are out there, because of the number of devices, we need to start thinking about a data-centric approach, and how do we combine forensics, security, static and dynamic analysis all together in a system that can then be searchable. And I think that we have to leverage things like automation and crowdsourcing to ultimately secure the future for us. So with that, I want to acknowledge our research and our engineering team, and really the whole team at Now Secure that makes this happen. We've got about 60 people. Whether it's the people that get the bills paid or sell the things, or the stuff that you guys end up seeing, which is really that research and engineering team. I wouldn't be up here without them. And I know I'm pretty much out of time, but I want to answer any questions if they come up, or until Renee kicks me off stage here. So are there any questions? Yes, sir.
Hi. About the UI automation that you mentioned, how do you know how to feed the fields? Let's say that the malware asks for the user email address. You need to identify what the malware is required in order to place it.
Yeah. So here's one of the things that, as a researcher, I want to look at every use case and say, I've nailed that. Some guy came up with some way to ask for this, problem and to ask for this data, and we caught it. The reality of it is, if you're building a system that scales and 90% of your problems have to do with just basic flaws, we built a system that addresses the basic flaws, and then we bring that human into the loop to identify that particular use case. So we found malware that basically uses like a native library to pop up a GUI that we can't expose the UI hierarchy. And so our rig just fails. But what we end up doing is every time it fails, we can pull a researcher off and say, that just failed right there. Can we code in a specific rule to deal with that property? And then can we make that more extensible? So we're basically focused on the primary use case, and then the one-offs, we go in there and we figure out what they did, and we just add that to the system and make the agent more intelligent.
Yeah, but how you identify that exactly that the application is failed in that point? When you place, let's say, an email address and you need to press a button, you don't really know what the reaction of the application will be.
Yeah, so I think two things. One, it's very possible that a lot of early on cases where somebody snuck something through will get through the big analysis, that we're doing right now. But the second thing is when you think about malware, you've got to take somebody like my dad, who can barely use a phone, right? And he's got to be able to type something in there so that they can get what they need to then lock down his phone or get his information. So there are things that happen on the screen, and we're exercising the app the way a normal user would. If you're going to write a piece of malware that affects Joe User, then our UI automator kind of acts like Joe User. It doesn't know all the different stuff. So I guess my point is that there are a lot of use cases early on that sneaky things going on when somebody wants to circumvent the system. It's just going to get by, and we're not going to catch it. But there's so many flaws that we found in that larger set, and then we put the kind of individual, that human, on that one-off case, and we just have to go out there and try to understand what they did and say, all right, here's a technique we're seeing that's being used more and more. Let's deal with that in our code. So it's just manual exception right now.
And one more question. What about the static analysis? On what level you are doing a static analysis? About a file list, strings on the DEX file, manual reversing, auto-reversing of the DEX file, native level?
All the first three, yes. In native level, we do not do automatically at this point. And so the way that we built this system, if I may go back one or two slides, It's just that today we're doing, AndroGuard and a couple others and some basic things that we do, right, on our own. But you can plug in any new engine that you want and just reprocess. So when somebody comes up with an interesting way to identify something that we didn't think of, oh, great. Okay. Just pop that thing in there, re-queue up a million apps, and let it run just with that new engine. But today we're using things like AndroGuard, and we do strings, we reverse the code, basic stuff.
And how you combine the analysis of the dynamic and static analysis together?
So that's where we wrote a lot of our own custom code. Everything becomes a key value pair that sits under the package name. For instance, we have one that just says PCAP, and then it links to an S3 file that's a PCAP file. But then when we process that PCAP, we come out with things like URL encoded, like what are the different properties, and we just expose them as kind of individual properties, key value pairs. And so we've built out this indexing engine that is very extensible, and we literally just take the values, key value pair them, and then we index them from there. And so
it's like you need to run the APK over and over again in order to...
No, I think you have to run it at least once, and sometimes we'll find that we have a new engine, or maybe we made a mistake and we need to rerun them. But one of the values of by storing every log file, every PCAP, the file system, is that if we end up finding a flaw somewhere, we may be able to go back, not run any app through, and just go through all of the analysis that we already saved out in S3, and we could do an analysis there and never have to rerun it. That's the goal.
Let's take the case of...
I mean, just to see, are there other questions too? Anybody else have questions? And okay, good. Go ahead. Sorry.
Let's take the case when you have an APK that's downloading a DEX file from a remote server. Do you know that in this case you need to also analyze, to do a static analysis to the new DEX file?
Yeah. Yeah, definitely. So of course we're doing things like, SHA-1 signatures and whatnot, and we look at version numbers and whatnot, but everything's based off of SHA-1. So if somebody has the same package name and even the same version and number, but it has a different SHA-1, we'll queue that up and we'll run that one.
Thank you.
Yeah, thank you. There's a question in the back, if we're okay.
So your work shows that we have really big problem, yeah? But the question is, did you think how to improve the situation? Did you think about approaches, how to provide kind of feedback to developers so that they could improve their systems?
Yeah, absolutely. So I didn't focus on that today. That is essentially the point of our company. So what we end up selling to enterprises is a tool that allows them, we call it Lab CI, Lab Continuous Integration. So every time their developers check in and there's an automated build, APK or IPA, we'll queue it up to this system. They run it internal. It goes through all those problems, and then it doesn't just come back and say, hey, you sent this in the clear. It says, in this function, you sent this, you use this technique, and you should be doing over here, you failed this OWASP and this CWE, and here's how you go fix it. So we're focused on giving those developers kind of as near real-time information about you just created a flaw, or we discovered some new problem with media server or SSL, whatever it is, and here's how you go fix it.
As far as I understand, the enterprise is actually a company who would install this app, but they are not developers at the same time. Yeah, so can they patch the application in some way?
Can the enterprises patch the application?
Yeah, or maybe did you think how would you provide some means to patch the vulnerable application?
Yeah, so that's really more of a overall platform problem for, let's say, Apple and Google to be able to deal with. What we do for companies is two things. One, they have their own mobile apps, sometimes hundreds of them, and we help them kind of make sure that they never have flaws. And the second thing that we do is we say, by the way, your customers, your supply chain, your employees, they're running all these apps. Go hit our Intel feed and go see what data is leaking out about you. So while we can't come back and say, here's how you patch that taxi application in Brazil, we can at least say, that taxi app is leaking out all this information about your CEO. If you don't like that, here's a better taxi application that's written better. So the patching that we do for third-party apps for enterprises is just driving visibility to the problem and then helping them make better choices.
Didn't you think about some solution like cloud AP test? Run the patients and test if they leak some information so that they could go over like another step and fix their problems.
So if I understand the question, because it cut out a couple of times, I think what you were describing is can we make it so that developers can kind of automatically run these tests while they're doing the development? That's 100% what we've built. So we call it lab continuous integration, but the idea is every time they build it, we're examining the APK and IPA, so we don't do it while they're typing their code, but as soon as they compile that, we'll go out there, try to find those problems and saying, hey, this is broke, go fix it.
Okay, thank you.
You're welcome. Great. Well, thank you guys. I'll be around for the rest of the conference, and myself and Pa would love to connect with you guys. This is an amazing group of researchers and academia here, so we're really excited, and thanks for the opportunity.